Hi, welcome to my channel, The Magic of Math, where we master math one video at a time. Today, my lesson is what is a rational number? Our objectives today are that you will understand that a rational number is an integer divided by an integer. You will classify rational numbers, integers, and whole numbers, meaning you're going to put them into sets or categories. And you will be able to convert fractions to decimals, and vice versa. Actually, you're going to convert decimals to fractions as well. The question I want you thinking about today as I proceed through the lesson: what numbers are not rational numbers? So our lesson today is what is a rational number, but sometimes understanding what is a rational number, you also have to understand what is not a rational number. So hopefully by the end of the video today, you'll be able to answer this question. And the title, what is? So what is a rational number and what is not a rational number? Let's begin with some vocabulary. So our title is what is a rational number? So let's define it. By definition, a rational number is a quotient of two integers. So that means two integers that are being divided, it's their answer. Quotient is the answer when you divide, which could be a repeating decimal or a terminating decimal. And I'll go over these further in the video. 3/4 is an example of a rational number. It is the integer 3 divided by the integer 4, making it a rational number. It's the quotient of 3 and 4. We also have 7. That might confuse you, thinking that 7 is a whole number. You've been talking about 7 probably your entire math career. But it could be written as 7 divided by 1, the quotient of two integers. 7 divided by 1 is 7, making it a rational number. It satisfies the definition. Now let's review integers. Integers, just to remind you, are whole numbers and their opposites and 0. So we have it extending infinitely in the negative direction, infinitely in the positive direction, anchored here by 0, and increasing by 1, 2, 3, 4, 5. And then our opposites, the opposite of 1 is -1, and I continue going more negative with my negative opposites of my whole numbers. Then we have whole numbers, and whole numbers are the positive integers and 0, or sometimes referred to as your counting numbers. So 0, 1, 2, 3, 4, 5, and extending infinitely in the positive direction. Now I mentioned that terminating and repeating decimals were also rational numbers. A terminating decimal is a decimal that ends. So 0.5 is an example. It ends. There's no repeating sign, there's no other digits, there's no ... telling you it extends infinitely. It ends, it terminates. A repeating decimal is a decimal that has a repeating pattern. So for example, we have 0.333 and we have the ... extending it infinitely. Or it could be written as 0.3 with this repeating bar. This bar right here, which I'll talk about in a minute, tells you that this digit repeats infinitely. So a repeating decimal is a rational number, as is a terminating decimal. So both terminating and repeating decimals are rational numbers since they can be written as fractions. Actually, in 8th grade math, I have a video that tells you how to take a repeating number and turn it back into a fraction, which is pretty magical actually. And then I will show you today how to do a terminating decimal using long division. So understanding that 0.5 can be written as 1/2 or 1 divided by 2, or also read as 1/2, and I will show you how to do that again later on. 0.3 repeating, you're going to have to take my word for it. Sometimes we just get used to it. This can be written as 1 divided by 3, and I'll show you the magic of, you'll know today how to get from 1 divided by 3 or 1/3 to 0.3 repeating, but in 8th grade I show you how to go in reverse. You just have to take my word for it for right now, or jump ahead to that video. Have you ever wondered about this little line above a repeating digit? It's called Vinculum. It's a big word. You don't hear many math teachers use it. Sometimes some use it just to make themselves sound fancy. I added it in this video just to give you a little trivia. And vinculum is Latin for chain. So in math, this horizontal line above a number represents that it's a non-terminating but a repeating pattern. So remember, a repeating pattern in a decimal makes it rational. So that's why it's important to understand. So this vinculum, or this repeating sign, as most of my students refer to it, and I'm more than happy to hear that, just means that this represents an infinite amount of threes going on for an infinite amount of time. It never stops. So note that this repeating pattern could be more than one value. You'll see that later on in the video as well. So it could be that this little vinculum, the little horizontal line, the repeating symbol is over multiple digits. So it could be over 2. It could be, 2, 4, 2, 4, 2, 4, and you would just have to put one set of 2, 4. It could be 4 numbers. It could be 1, 2, 3, 4 with the vinculum on top of that, meaning that the pattern is 1, 2, 3, 4, 1, 2, 3, 4. So keep in mind, it's not always just on one digit. So we have also to understand what is not a rational number. So if you have a non-terminating, meaning it extends infinitely, and non-repeating, meaning there's no pattern, there's no horizontal bar, the repeating symbol, or the vinculum on top of a number, so it indicates that it's not a repeating pattern, we need to understand that non-terminating and non-repeating decimals, they're not a rational number. So a number that is non-terminating and non-repeating decimal is not a rational number. Decimals that do not have a repeating pattern and do not terminate are what we call irrational numbers, which again is an 8th grade topic. This is a 7th grade video. So they're irrational and not part of the rational number family. Now, although you're only in 7th grade, or maybe you're watching this as review, you're all aware of a number pi. You've probably played with pi on Pi Day in March 14th, and done some investigations relative to circumference of a circle. Well, pi is not a rational number. Pi represents a decimal that does not have a repeating pattern, but never terminates. It does not end. It goes on infinitely with 0 pattern. So there's no rhyme or reason to these digits. You can't find a pattern and then just memorize those digits and have it repeat. I know some students have a challenge where they're like, can you memorize 100 digits of pi? So pi is non-terminating, non-repeating, and an irrational number, which is not part of the rational number family. So just keep that in mind. Here is a Venn diagram. We use a Venn diagram, which is overlapping circles. So you can see that I have my pink circle inside of my yellow circle, and both the pink and yellow are inside the green circle. We use this as a visual relation to show a visual relationship between 2 or more sets. So I'm going to show you right now the relationship between rational numbers, integers, and whole numbers. So with this Venn diagram, I can show you how they're related. So let's pop up some numbers here. And these are all rational numbers. I haven't put any tricks here. And we have to put them into the Venn diagram, into one of the sets. So let's start with negative 21. Negative 21 is most specifically called an integer. So it's negative, but it's the opposite of positive 21. So it fits into the integer category. Understanding that integers are also rational numbers. So although I've put it in the integer category, it is an integer and it is a rational number. So keep that in mind. So think back to when you learned in geometry about a rectangle and a square. A square is by definition also a rectangle, but that's not specific enough. So we call a rectangle that has 4 congruent sides a square. So even though negative 21 is a rational number, it's more specifically named as an integer, but it's still also part of the rational number family. Let's move on. 6 over 3. Before I can place this value, I have to simplify it. 6 divided by 3 is 2. So although it can be written as a fraction, it simplifies to 2, and I put it into the whole number category. So because it is simplified to 2, it is a whole number. But remember, whole numbers are also integers and also rational numbers. So 6/3, which is equivalent to 2, is a whole number, an integer, and a rational number. And by putting it in this middle circle here, it's telling me that it's part of all the circles. Next number is 135. That is a whole number and belongs in the whole numbers. Again, 135 is a whole number, an integer, and a rational number, because I could write it as 135 divided by 1. Here we have 0.4 repeating. That is a rational number. It is a repeating decimal. That is not integer or whole number. So notice it's only in the green. So if it's only in the green, it only belongs to rational numbers. 0 is a whole number. So it's a whole number, an integer, and a rational number. Then I have -4, or -4 divided by 2, which simplifies to -2. So now that I have it simplified, I can make it be an integer, and -2 is also a rational number. 2 divided by 5 is a rational number. It cannot be simplified to an integer or a whole number. 0.7 is also a rational number. It cannot be simplified to an integer. Now I want to talk a little bit more about our Venn diagram. So if I take away my whole number circle, this is still accurate. So it might not be as specific as I had it before, but all of these values are also integers. And if I take away my integer set, now all of these values are in the rational number circle. So I just want to give you this visual representation of this, that all of these values are rational numbers. But more specifically, if I bring it back, these are all integers. So everything in the yellow is an integer and a rational number. And let's bring back our whole numbers. So our whole numbers are whole numbers. They're also integers and also rational numbers. And before we go on, I want to bring up our set of irrational numbers. These are numbers, they're not rational numbers. The only one that you know about right now is pi. You'll learn about more in 8th grade. But pi is not rational, it is irrational. And irrational numbers do not belong in this set. So they're not part of the rational numbers or integers or whole numbers family. They're their own family, and their circle does not overlap or overlay inside of these rational numbers. So you would draw it as its own circle next to it. All right, your turn. Now that we've reviewed this, I'm going to show you this example, and you have these values: 0, -8/4, 5.8, -2.0, 5/7, -5.43 repeating, and 1,948. I would like you to pause the video and determine which of these, you can just put it on your paper, is 0, rational, integer, and whole, and you'll have to select each. So on some numbers, you might select all 3, some only 2, and some only 1. Go ahead and pause. Come back when you're done. Welcome back. Let's see how you did. So first, we're going to go over 0. 0 is a whole number. It's our first anchor to our counting numbers. It is also an integer, and it is also rational. Then we have -8/4. So that's -8 divided by 4, which simplifies to -2. -2 is an integer, a rational number, but it is not whole because it's negative. Remember, whole numbers cannot be negative. Next, we have 5.8. Because it's a decimal, I know it cannot be an integer or a whole number, so it is only rational. Here's one that seems to trick some students: -2.0. At first glance, they tell me, well, it's a decimal. Well, it's written, but 0.0 is not what we call in math significant. Because if I write this just as -2, it's equivalent. So if I can remove the decimal and it still represents the value, then that means 0.0, although accepted, is not significant, and this truly isn't, by definition, a decimal. So we really have -2, which is an integer and a rational number. It cannot be whole because it's negative. Our next value is 5/7. This is 5 divided by 7. So I have two integers being divided, making it a rational number. It's in simplest form. Then our next value is negative 5.43 repeating. So I have a repeating decimal and it's negative, so it's only going to be rational. And our last value, 1,948. This is going to be a whole number. It's also an integer, and it's also a rational number. Try another one. I would like you to practice classifying all these values. So I have 189, negative 9/3, negative 1.375 repeating, 7/8, 1.5896, 1, and negative 17.0. Please pause, select the sets that the numbers belong to, come back and hit play when you're ready. Welcome back. So 189 is a whole number, it's a rational number, and it's an integer. Negative 9 divided by 3 can be simplified to negative 3, making it rational and an integer, but it cannot be a whole number because it's negative. Negative 1.375 repeating, it has a repeating decimal, so it has a pattern, so therefore it is a rational number. 7 divided by 8, or 7/8, is by definition an integer divided by an integer, making it a rational number. 1.5896, this is a decimal that terminates, it ends. There's no repeating horizontal bar, no vinculum, so it is a rational number. The number 1 is rational, it's an integer, and it's a whole number. So it belongs to all three sets. Negative 17.0, so 0.0 is not significant. It has the same value if I just say negative 17, so that makes it rational and an integer. Now let's talk about writing a fraction as a decimal. To write a fraction as a decimal, we're going to divide the numerator by the denominator. So I have negative 4 and 3/5 here, but I'm going to make myself a little note. This is going to be equal to negative 4 point something. I just need to find out what the 3/5 is equal to. So 3/5 is a division problem. It is 3 divided by 5. So let's set up our long division. I know that 5 cannot go into 3, so I need a 0. I'm going to add my decimal point and carry it straight up and add another 0 digit. It's insignificant, so I can add as many zeros as I need. So because 5 does not go into 3, now I'm going to look at 30. 5 goes into 30 6 times. 6 times 5 is 30. 30 subtract 30 is 0. So when I have a remainder of 0, I'm done. So I know that 3 divided by 5 is equivalent to 0.6 or 0.6. So now that I've already started, I have negative 4 from my whole part of my fraction, and I'm going to add the decimal portion, which is 0.6. So negative 4 and 3/5 is equivalent to negative 4.6. Now let's talk about writing this fraction to a decimal. So I just have 5 divided by 11. So remember, all fractions are division problems. So I'm going to do 5 divided by 11. So let's set up our problem. I'm going to add another digit. I'm going to carry my decimal point up, and 11 does not go into 5, so I'm going to start with my 0. 11 goes into 50 4 times. 4 times 11 is 44. 50 subtract 44 is 6. I need another 0. I'm going to add a bunch. You can add as many as you need. Bring down the 0 because 11 does not go into 6. 11 goes into 60 5 times. 5 times 11 is 55. 60 subtract 55 is 5. So I still have a remainder, so bring down another 0. 11 goes into 50 4 times. 4 times 11 is 44. The 50 subtract 44 is 6. I'm going to bring down another 0. And I know that 11 is going to go into 60 5 times because 5 times 11 is 55. So you can kind of see I'm having a pattern. I had 44, 55, 44, I have another 55. And if I look up here, I can see my repeating pattern, 4, 5, 4, 5. So I can come back over to my fraction, and I know that I need to use the vinculum or the repeating bar over the two digits, the 4 and the 5, because they both repeat. So this is going to go on infinitely. You could keep going. I'm going to stop, but it goes 4, 5, 4, 5, 4, 5, 4, 5. You could go infinitely. It will never terminate. So there you have it. 0.45 repeating is equivalent to 5/11ths. Your turn. I would like you to write each of these fractions as a decimal. Go ahead and pause. Come back when you're done. Welcome back. So let's see our solutions here. So I'm going to make a note that this is going to be a negative. I don't want to lose that negative sign. And it's not a whole. There's no whole value here. So I know that I'm going to have 0 point something. Let's set up our long division. 11 divided by 50. I need to put my 0 and my decimal point. You carry your decimal point straight up, and I have to put a 0 here because 50 does not go into 11. So now I'm going to look at my first three digits, 110. 50 goes into 110 twice. 2 times 50 is 100. 110 subtract 100 is 10. 50 does not go into 10, so I'm going to bring down a 0. 50 goes into 100 twice. 2 times 50 is 100, and now I have a remainder of 0. So this is a terminating decimal because I no longer have a remainder. There's no more long division I can do. So I'm going to carry up my digits up to my answer that I've already prepared with my negative sign, and I add my 2 decimal places. So negative 11/50ths is equivalent to negative 0.22, or you could read it mathematically, negative 22/100ths. Now let's go over 2 and 2/9. I'm going to set up my answer. It's going to be equal to 2 point something. So now I just need to worry about 2/9 or 2 divided by 9. Remember, say it to yourself, 2 divided by 9. That'll help you set it up. So 9 does not go into 2, so I'm going to bring up my 0 and my decimal point. And now I'm looking at 20. 9 goes into 20 twice. 2 times 9 is 18. 20 subtract 18 is 2. Bring down your 0. 9 goes into 20 twice. 2 times 9 is 18 with a remainder of 2. And you can see what's going on here. If I brought down another 0, it's going to go in twice. So it's going to keep being 2. I'm always going to have a remainder of 2, and it will not terminate. It will not end. So I know that I can come up to my answer and put 2 with our vinculum or our repeating bar sign. And there I have it. 2 and 2/9 is equivalent to 2.2 repeating. Now let's talk about how to write a decimal as a fraction. To write a decimal as a fraction, you first say the number mathematically, and it will help you. So let's look at 0.36. Some math teachers won't let students say that. They want them to read it mathematically. It makes you communicate that you understand what it represents. So if I read this mathematically, I say 36 hundredths. So I have my tenths, my hundredths, thousandths, 10,000ths. So we've learned about our digits and what they represent, and we're going to use those to help us write this decimal as a fraction. So 36 hundredths can be written just as it sounded, 36 hundredths, because we're using the THS, the hundredths, not hundred. It's our denominator. So 36 hundredths is just as it's read, 36 divided by 100. Now here's the catch. This is not in simplest form. I know this because both 36 and 100 are even numbers. So I know that they're both divisible by 2. But I've been doing this a long time, so I'm going to show you something else. I'm recognizing that I know these values are both divisible by 4. If I divide 36 by 4 to simplify, I must also divide 100 by 4, which gives me 36 divided by 4 is 9, 100 divided by 4 is 25. So 9/25ths is equivalent to 0.36 or 36 hundredths. Now let me show you another way, because you may not have looked at this and noticed that both of these values were divisible by 4, and you're looking for a number that they're both divisible by. So meaning you couldn't divide the top by 4 and the bottom by 5. They have to be divisible by the same value. So let's erase this. You could have also said, because they're both even, we know all even numbers are divisible by 2. If I divide the numerator by 2, I must divide the denominator by 2. 36 divided by 2 is 18. 100 divided by 2 is 50. Now, they're still both even. That means they're still both divisible by 2. 18 divided by 2 is 9, and 50 divided by 2 is 25. I got the same answer, I just did it in 2 steps. Sometimes I encourage my students to do it in smaller chunks like this because it's easier math in their heads. So 9/25 is our solution to 0.36 or 36 hundredths, decimal to fraction. They represent the same value. Your turn. I would like you to write the decimal -3.52 as a fraction in simplest form. Please pause, come back when you're done. Welcome back. So I'm going to make a plan. I know that I have the whole part of my fraction is -3, and I only have to worry about the 0.52. That's the fraction part. That is read as 52 hundredths. So -3 and 52 hundredths is equivalent to this decimal. Now both 52 and 100 are even, meaning it's not in simplest form. So I'm going to divide both the numerator and the denominator by 2. 52 divided by 2 is 26. 100 divided by 2 is 50. They're both still even. Both the numerator and denominator are even, so we're going to divide both the numerator and the denominator by 2, leaving us -3. 26 divided by 2 is 13. 50 divided by 2 is 25. 13 is a prime number and not divisible by anything but itself in 1, so I know I'm done. -3 and 13/25 is equivalent to -3.52 or -3 and 52 hundredths. Now we're going to use a number line to order rational numbers. So graphing values on a number line is a great way to visualize and order, and this helps keep track of things so that we don't make errors. So here's my number line. You can see that it's going up by fourths. 1/4, 1/2, 3/4, 1, 1 1/4, 1 1/2. Going backwards the same way, to the left, -1/4, -1/2, -3/4, -1, -1 1/4, -1 1/2, -3/2 is the same as saying -1 1/2. So we're going to order from least to greatest these values. 5/4, which is also 1 1/4, -1, +1/2, 0, and -3/4. So 5/4 is going to be 1 1/4. Remember, if we wrote this with a denominator of 4, we have to multiply both the numerator and denominator by 2, which gives me 6/4. 5/4, 6/4. -1 goes way over here, plotting -1. +1/2, we plot that point here. 0, we plot that point. And -3/4 is going to be right here. Remember, -1/4, -2/4, -3/4. So now I have them all here, and we order from least to greatest. Remember, left to right, least to greatest. So in order, we're going to have -1, -3/4, 0, 1/2, 5/4. So you can see how creating a number line and plotting your points will help you write these in order. Your turn. I would like you to pause, order these values from least to greatest, and come back when you're done. Welcome back. So with these three, one strategy I have is I'm looking at them and only one value is negative. So I know that is my smallest value and I can start my least to greatest with -7. Then I'm looking and I have a fraction and a decimal. So I'm going to convert, if you're going to compare numbers, they should be in the same form. So I'm going to convert 7 2/5 to a fraction, or to a decimal, this fraction to decimal. So 2 divided by 5, 2 divided by 5, 5 is going to go into 20 4 times. 4 times 5 is 20, and I get a remainder of 0, meaning it terminates. So this is 7.4. 7.4 is less than 7.8, and there I have my values in order. So you could have used a number line, but I converted, and so I knew my negative was the least, and then I converted these to be both decimals. Now we can use a number line to compare values. I have compare -1/4 and -5/4. And when we compare, we use less than, greater than, or equal to. So let's graph our numbers. I have -1/4 graphed, so 0, -1/4, -2/4, -3/4, -4/4, -5/4. So there's our second value. So I have both values on the number line. Now, we're starting with this. They're saying -1/4, which is this point. This point is closest to the greater than sign. Notice that it's right here, it's to the right, and it's closest with not coming in contact with the other value. And notice the greater than sign matches the arrowhead. So this is going to be greater than -5/4. So just a little trick. If the first number is the one furthest to the right and there's nothing between it and the end of the number line, then that arrowhead also tells you what sign to put in the box. Now let's try this one. We are going to compare -3/4 and 1/2. So -3/4 on the number line is right here. -1/4, -2/4, -3/4. 1/2 is positive and right here. But this number is first. This time the least value, the smallest value, is first on the number line, and that's our first number here. So it's closest with nothing next to it to our arrowhead that looks like this. So that is less than. So we know that it is -3/4 is less than 1/2. So use your number line to help you visualize whether you're doing less than or greater than. Your turn. I would like you to compare these pairs of values with less than, greater than, or equal to. Come back and hit play when you're done. Go ahead and pause. Welcome back. So I have -7/2 and -3 1/2. And those values are equal. If I write this as a mixed number, 2 goes into 7 3 times with 1 left over, which is -3/2, 1 1/2. Or I can say 2 times 3 is 6, plus 1 is 7, giving me -7/2. And those are the same value. It's just one is written as an improper fraction and one is written as a mixed number. Now I'm looking at -2 1/4 and -2 1/2. I'm going to use my number line. -2 1/4, I go over from 0 to -2, and I go 1/4. And so here's my value, -2 1/4. And then -2 1/2 is right here. And this is my first value. So I'm stating that -2 1/4 is greater than -2 1/2 because there's no other point plotted between it and the greater than part. So there we have it. That is what is a rational number. So I hope you are able now to classify and identify rational number values, and that we have reviewed how to convert fractions to decimals and decimals to fractions. I hope you'll come back and join me here again at the Magic of Math, where we master math one video at a time. Please subscribe to my channel and sign up for notifications for new videos that I post, and I hope you all have a great day.